but I think I'm going to use the overhead. Yeah, I agree with you though. Right now it doesn't make the most sense, but we weren't around when they made the choice, so we couldn't even put our say in.
We've seen less sense since we don't really know exactly what sine and cosine and all that stuff actually means.
Do it again. I'm sorry.
It makes even less sense when we don't really know what sine and cosine and tangent actually means.
Well, we do know that, don't we?
Well, we kind of have an idea.
No, we totally know what it is. I need you.
Sine is y over r.
We're gonna do a ton of weird shit with all the trig functions. We're gonna kind of like put them together, reorganize. When we created the Pythagorean identities, it's the first level of weird stuff we could do with them. You start to lose touch with the fact that they come from ratios of sides of right triangles. But that's what they always are. We're just gonna do more and more stuff with them, and we're gonna get further and further away from that idea, but they are always just ratios of sides of right triangles. That's all they ever are. Yeah. Okay. But let me ask you this. Can somebody tell me what's before I get into that, I just remembered, I don't want to forget this. Is this radians or degrees?
Radians.
Yeah, how do you know?
Because there's no difference.
Yeah, so if I tell you it's an angle and I just put a 3, it's got to be radians. The only way it could be degrees is if there's degrees. Yeah, if it's not degrees, it must be radians. That's our two options that we have. Is that cool? That's one thing. Is there a pi in there?
No.
No! So does it need to have a pi to be radians? No. 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 So isn't it, can somebody do in their calculator what pi divided by 6 is? If you have a calculator, what is pi? You know where the pi button is divided by 6.
0.52, 359.
Isn't it easier to say, what's the sign of pi over 6 instead of what's the sign of 0.52 blah, 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 blah?
Yeah.
So that is the reason, the only reason that some radian degrees, some radian angles have pi in it, is because it makes it look cleaner. We can memorize pi over 6 is 30 degrees. They both reference the exact same kind of size angle. Are you guys with me? But that doesn't mean that a radian has to have pi in it. In fact, is this radians or degrees?
Degrees.
Freaking degrees is like 3.14159 degrees. Okay. You guys semi with me. Okay. Okay. All right. I'm not sure if you get the point, but don't force a pi in just because it's radians. No. If you solve for theta and you get 0.539765, you don't have to put a pi in there. No, no. Is that, you guys with me? It's just the main angles we write with pi because it makes them easier to remember. They look cleaner than 0.52 blah blah forever. I'd much rather write pi over 6. Okay, that's one thing. Now, coming back into where we just left off earlier. Can somebody tell me what a function is? Tell me anything about a function. Anything. Sure.
A function is a set of inputs that give you an output.
Kick ass. I love that shit. Can somebody give me an example of any function? Anybody?
X squared.
No, yeah, sure. Go ahead.
F of x equals x squared plus 3.
Kick ass. All right. Sorry. I'll come back. Is everybody with me so far? All right. So that you've seen that kind of function before, correct?
Yeah.
Come on. Wake up. There you go. Okay. Here we go. So real quick, if I have f of x equals x squared plus 3, and if I had a pen, everything would be so much easier. There we go. Okay. Real quick, guys. Real quick. Get in there. Okay. You all agree with me that if I have this, what's this? Hold on. Oh, Jesus. Why are you not working? There you go. So many buttons to push. If you have this blurry mess. All right, blur again. Oh, good. No, blur it again. It's going to come back. Okay. You all agree that I could put numbers in and get numbers out. And just like you said, there's inputs and then there's outputs associated with those inputs. Every input only makes one output there. You guys agree with me so far? You guys agree with me? Yes. Okay. Anything that gives me an output for any input is a function, right? So if I put 0 into sine, what's the output? Sine of 0 is 0. You guys with me? What's sine of pi over 6? Good, because pi over 6 is still small. Sine still doesn't like it that much. It's going to be 1/2 the smaller one. Are you guys kind of with me? So every input you can imagine has an output. So we're, again, just remember, every step we take in this class, we're going to get further and further away from feeling like trig functions are just ratios of sides of triangles. And right now we're just realizing, okay, they're ratios of sides, great. That means for a certain triangle input, I'm going to get an output for every trig function, correct? So they are functions. And what else can we do with functions besides just throw stuff into them? We can graph them. Because then I have inputs and I have outputs. I can plot points, I can graph them. So that's what we started doing last time. So today what I want to do is I want to show you some shortcuts about graphing these things. Instead of applying every single shift. So last time we talked about what happens if I put, for example, let's see if you guys remember this. What if I put in here, what would that do?
Shift to the right pi over 2.
Yeah, it would shift right by pi over 2. But it would so desperately suck if I had to apply each shift to the damn picture. My God, Jeff. There must be some shortcuts we can take, and there are. But I wanted last time just to remind you guys about transformations, about what they did, so then the shortcut would make more sense. We're just kind of shortcutting, applying every single transformation. So, what I want you guys to do, can you guys, without saying anything, can you please graph cosine x? Doesn't have to be beautiful, but I want a clear scale. I want clear points. Everybody should be able to do this. Let me help you out just a little bit. What are like the main 4 things here?
Pi over 2, pi, 3 pi over 2, 4 pi over 2.
I like it. I'm with you. Alright, so graph cosine on that scale. Don't put anything in your calculator. Again, we're just marrying what we have memorized. You have all this stuff memorized. And if you don't, this is bad. We have all this stuff memorized, and we're just plotting it now. We're just applying the idea of function. If I know an input with an output, I can put that on a graph. So somebody remind me, what is cosine of 0?
1.
Because that's cosine like x, starts on the x-axis, it loves it there, it's happy, it's a full 1. Now, pi over 2 is also known as the what axis?
Y-axis.
The y-axis. So if I go to pi over 2, I'm on the y-axis. Does cosine like it there?
No.
No, okay, good. So we have all these ways to memorize this stuff. Some of us are probably beyond that. You don't have to think about that. Cosine of pi over 2 then would be 0 because it doesn't like it there. Cosine likes x. If it's all on the y-axis, there's no x piece. Cosine hates it. It's 0. What's happening at pi for cosine?
It's
Negative 1. 3 pi over 2 is another 90-degree thing, so it's going to be 0 because that's on the negative y-axis. Cosine doesn't like it there either. And of course, 2 pi, I get back to 1. Okay. Does anyone have any issues with what we just plotted? Yes?
So would it be safe to say that for cosine of x, that it really doesn't like pi, since it's wanting it to go backwards?
Oh, I see what you mean.
Yeah.
I always think about that like, I don't know. I don't think of it that way. I just think it's in that direction. it still loves the x-axis, so it's gonna be some maximal amount, either -1 biggest negative or 1 biggest positive. Does that make sense? Here it totally doesn't like it. There's no x piece to this.
Yeah.
That's why it's 0 there. Does that make, but whatever makes sense to memorize, right? That's the way it makes sense to me. Yeah. But I know what you mean, yeah.
If it likes the x-axis, why would it want it to be positive?
Oh, okay. I got you. So if I fill in the shape, don't make a V. Does anyone know what that would be if I made a V?
Oh,
Absolute value.
Absolute value. So we know it's not that. I know it's not linear. It's got to be curvy. So it's going to be the top of the hill here, and then the bottom valley, and then back up to the top of the hill. And I always go a little bit further just to show that it continues forever, right? How much of this did I just graph officially, ignoring the little arrows? One cycle that fits in one period, right? Now, let's analyze the hell out of this. What's the period then? I basically just gave it away, but what's the period? 2 pi. What else has a period of 2 pi?
Circle.
Negative.
Oh, okay, I'm with you. That's, of course, that's where it comes from. But what other trig function has a period of 2 pi? Sine. In fact, sine and cosine look the same, don't they?
Yeah.
They're just offset by 90 degrees, which kind of makes sense. Sine is 0 here, cosine is 0 there. That's off by 90 degrees. So if I move that 90 degrees over, I get the sine function. Is everybody with me? Okay, maybe. If I moved it this way 90 degrees, wouldn't I just get the sine function? Starting at 0, okay. So the period is 2 pi. How many steps did we just graph? How many steps did I take? I took 1, 2, 3, 4 steps. Yeah? You guys see that? And real quick, I need you to understand. If I just freaking squeeze this thing or stretch it, move it up and down, aren't I always going to have these major points? This is where it's the biggest positive. This is where it's 0. This is where it's the biggest negative. I always want to find where those are happening. I need this to make sense. If I knew where it was the biggest, where it was 0, where it was the biggest negative, I could just fill in the shape. So if I squeeze this, what's going to change? If I squeezed it, the period's going to change. The period's going to get smaller. Is that cool?
Yeah.
If I just press it, if I squeeze it, it's going to fit into a much smaller range. Are you guys kind of with me?
Would it still be 2 pi?
No, the period would change if I squeezed it, right? So we'll get back to what makes that happen in a minute, but here's the idea with the step size. So the period's 2 pi because that's how long it takes for a cycle to be drawn. So whatever the trig function we're looking at, the period will always be how long does it take for you to get through one complete cycle. Okay. The step size, we just kind of gave it away. How many steps did I identify?
4.
1, 2, 3, 4. So it's going to be 2 pi cut in fourths. And for this one, it's not going to be too amazing. How big is each step I take? You already know. 5/2. And sure enough, what's 2 pi divided by 4? 5/2. Kick ass. So one really good thing to know, if I have a trig function that has been shifted, it's been compressed, it's been stretched, it's moved around, one of the very first things I can figure out is, what's the new period, and how big is each step size? Because every time I take a step, I hit another key thing. So, does everybody agree with me that between 0 and pi/2, it's got a lot of outputs? That's why we drew a line there, right? It's got an output of pi/4, it's got an output. But the important points, the what I call anchor points, are where is it 1, where is it 0, where is it -1? Those are my anchor points. Okay, you guys semi with me? Believe in me, trust in me, we're going to make a beautiful, relatively easy way to graph any freaking trig function they give me that's been moved around. Okay. Now, let's see. Oh, so let's do. Let's see. Do I want to do a little baby example? No. One other thing I want to remind you guys about is if I wanted to change how high up it went and how far down it went, what would I do?
Coefficient outside.
Yeah. So let's kind of keep track of a couple of things. So if I have a number in front of the cosine, and it's kind of nice we use the letter A because that's related to the
Amplitude.
amplitude. if I have a number in front of my x like this,
You're dividing it by that number.
dividing what?
Period.
Yeah, so this would change the period. We talked about why that's true last time. Okay, I like it. So for example, very quickly, just remind, so this, the new period would be the old period divided by k. Stop for a minute. We figured that out last time. I'll do an example real quick to show you why that's true. So this is pretty much catching up where we left off last time. There was one other thing we did that I'm gonna bring in a minute, and that's moving it left and right. I think we didn't do an example of that yet, but I mentioned it. Okay. So let's do this. Let's do a concrete example of a period change. Let's just focus on the period change. There. All right, so what is the value of k?
1/3.
1/3. Don't say anything. What's the new period? Figure out the new period. Don't say it. If I could just draw a 3, it would be amazing. All right, who thinks they know the new period? Anybody else? I know you know it. Hold on. Anybody else got the new period? How do you do that? How do you divide by a fraction? Why is multiply by 7? So what is the new period?
6 pi.
6 pi. Is that cool? So we talked about this last time. Do you guys remember that if it's inside with the x, it does the opposite of what it looks like? So inside it's got a 1/3. It seems like it should cut it by 1/3, but it actually does the opposite because all of my inputs have to be 3 times bigger than they used to be because the first thing the damn thing does to me is cut me in thirds. Shit. So I used to have to go to 2 pi. Now I've got to go to freaking 6 pi because 1/3 of 6 pi is 2 pi. You guys kind of follow. So this is what is called a horizontal stretch. I don't need you to know that name, but you understand why we call it that. It's just going to stretch it out. Did I move it left or right at all? No.
No.
What's the new step size going to be?
Well,
What do I always do? Within a cycle, I can identify 4 steps. Right? I start at 0, which for cosine is going to be where it's the maximum, and then I step 4 times and I find all the other key points. Are you guys at all with me? Okay. So if I just knew the step size, I can just plot those, put the points, and then connect them. So what's the new step size? I'm going to take 6 pi and I'm going to cut it in how many parts? We just said how many steps to get through a cycle. 4 steps. So if I take 6 pi and I cut it into 4 parts, I'll see when I'm going to hit each key next thing. When is it going to go to 0? When's it going to go to -1? So what's this? Help me out. 3 pi over 2. Please, dear God, don't ever make these decimals. Right? Can we stop for a minute? So it didn't shift left or right. What would have to be there for it to shift left or right?
addition or subtraction.
Yeah, minus or plus something inside, right? Okay. So I'm still going to start at 0 for my base cycle. But now the steps, what's the next thing I'm going to put here?
3 pi over 2.
Yeah, I'm going to step by 3 pi over 2. 2, Jeff. So 3 pi over 2, another 3 pi over 2 would be 6 pi over 2, which is 3 pi. Is that cool? You guys with me? So if I step 3 pi over 2, 6 pi over 2, what's the next thing?
9 pi.
9 pi over 2. I just keep stepping by 3 pi over 2. Again, all we're doing is we're taking what we know from the normal cosine here I'm stepping by pi over 2. If I take 4 of those steps, it does get me to 2 pi. I get my whole cycle. But here, every step I take has to be bigger, because now I got to make it out to freaking 6 pi. So I take a moment, how big is each step going to be? 3 pi over 2. And now I start doing it. 3 pi over 2, 6 pi over 2, 9 pi over 2. Add 3 pi over 2. Add 3 pi over 2.
6 pi over 2.
Add 3 pi over 2. 12 pi over 2, which
There we
is...
go.
So I know I got there. You guys would... Now again, just to remind you guys, I'm graphing one cycle. At the ends, we're going to put freaking arrows to show if you want more than that, get it yourself. We're just going to give one representative cycle, and then whatever else somebody wants, they can go get it. You with me? So here's the power of this idea of step size. At 0, where does cosine? At the first step, at the 0th step, where does cosine start?
1.
Yeah, it starts at the maximum. And then it goes to 0, negative 1, 0, 1. I need you to understand the only thing that putting a number in front of the x does is it changes, it either stretches it out or it compresses it. I'm still going to hit these main points. I'm still going to hit the maximum 0, the max negative 0, the maximum positive, right? I'm still going to hit those points. I'm just going to do it at different places than before because I'm stretching this thing out. So by figuring out the step size, I know when those things are going to happen. I don't have to be as precise in every calculation. I'm just capturing the general idea. Okay, let me stop for a minute. Yes?
So will we be required to label each point more than just the ones that we just labeled? So say
Let me put this in. Hold on. Let me do this. Right, now you can fill in the picture. Doesn't have to be perfect, obviously. That's all I need right there. That's all I need.
So you're not going to be required to do all the mini.
How many are there? What do you mean? How often is it going to do this?
Say in between 0 to 3 pi over 2 or 3 pi
no,
over 2
no,
between
no.
3 pi.
No, there's no need. We
Cool.
could. We totally could, right? Can somebody remind me what the cosine of pi over 4 is?
Right 2 over 2.
Yeah, which is roughly 0.7. So you could totally do something in the middle here, and that's supposed to be 0.7.
So you don't have
There's no need to be that precise. We're just doing this by hand, right? Does that make sense? You totally could. You guys understand? I totally could check my answer by doing some middle stuff, but you don't need to get the picture, right? When I'm graphing a parabola, how many points do I need? 3 normally. I need to know where the vertex is, and if I get 2 more points, I can do wah-ha, yee-haw, right? Well, let's make that a little bit. If I wanted to, I can get some little points in between, but I don't need to just to get the picture down. Does that make sense? So if I get these anchor points for one cycle, I can just fill the shape on top. We're doing this by hand. We're only human, so we're not going to be that detailed. This, if I ask you to graph one cycle of this, bam, beautiful, tier, kick-ass. Are you guys all with me? And does everybody understand the idea of the step size? It is just understanding that one step in, I go from 1 to 0. Another step, I go to -1. And why is there 4? Because if I take 4 of these steps, I end up where I'm supposed to end, right? So why is every step bigger here? Because I've got to overall get further. Everything's been tripled. And real quick, do you guys see that? This first step is pi over 2. What's the next step? What's the first step here?
3 pi over 2.
3 times as big, because everything has to be 3 times as big to overcome the 1/3 that the damn function is doing to me. Okay, we're still not at the shortcut yet. But this is pretty good. You can always figure out the new period. In fact, I'm always going to ask for it, and the new step size. So let me just do an ultimate holy shit problem. Here we go. And then I got a handout that actually kind of spells this out. Computer generated, which is much better than I could ever do. So, what are you going to do, Jeff? Let's do sine this time. 2x minus, pi over 4. let me do a couple of things with you guys. I threw some extra shit in there, correct? Nothing too much, but there's a little due here. So let's see how we don't have to worry about this. First thing I want you to do is identify what K is and then figure out the new period. Don't say anything, just do it. What is K and what is the new period? It's going to get blurry for a moment. Sorry. Holy crap, that really got in there. Come back. Okay. All right. What's K?
2.
K is simply whatever the hell is multiplying the x p's. That's all it is. So what's the new period going to be?
4.
Careful. So it's the old period divided by K.
Just pi.
Just pi. It is always the original period of the function I'm looking at divided by K. And again, that's exactly what we did here, yes? Yes.
Don't you have to move it over to the right?
Oh, no, I'm not asking about that yet, right? No matter how it's moved, real quick, you understand, if I added an extra thing in here and made this move, would that actually change the shape of this at all?
No.
At all.
No.
It would just pick it up and move it around, yes? So the left and right motion does not a damn thing to my period and my step size. It doesn't, it just picks it up and moves it. It doesn't squish it. Does that make sense? The most important part of this is how much does it get squished? The left and right motion is almost like an afterthought. Just move it. Okay, we stop for a minute. Okay, now, how big is each step going to be? What's the new step size?
Pi over 4.
Yeah, you always take the period, whatever it is currently, and cut it into 4 parts. Well, what's that? All right, let me stop for a minute. Is everybody with me so far?
How did you get pi over 4 again? As the new step size?
Step size. So how did I get the step size here? And why?
So you,
The period has kind of like how long on the x-axis it takes me to get through a whole cycle, and how many steps will always occur for the sine or cosine function. 4 of them, correct? You guys with me? And the idea, sine is beautiful, it's nice, it's got a lot of symmetry to it, so they can't be different size steps. So if I just take the period and always cut it in 4 parts for sine and cosine, I'll get the new step size. Because that's all steps are. I know it's going to take 4 steps. I don't care how big or how small my cycle is, it's going to take 4 steps to get through the whole shape. That's the idea. Whatever my new period is, if I divide it by 4, I'll see how big each step is. Yeah. Okay. Now here's the new part. This is all old stuff, right? Here's the new part. Where does sine normally start? For what input do we kind of like start things off? 0,
0,
right? And then we kind of draw from there.
Yeah.
And if I want to, I can go backwards, but normally start with 0. Are you guys with me? All right. So we normally start when the inside is 0, correct? Now watch, this is the key part. You ready? So I'm going to begin my cycle when the inside is 0, because that's what we normally do. I normally start when the inside is 0. What about cosine? Same thing. I start at 0, don't I? And then I put that on there. Yes? So don't I start when the inside is 0? So everybody with me? So when is the inside equal to 0? Solve for x, right? When is the inside equal to 0?
Pi over 8.
Yeah, so if I do 2x, I add pi over 4, and then I take 1/2 of both sides, pi over 8. Is that cool? I could always do that. Whatever the hell all this shit is, I could just take it, set it equal to 0 to see where I start. Now for a normal sine function, where do I end? When the input is Where do I end the cycle? When the input is
2 pi.
2 pi. Sine, cosine, we go from 0 to 2 pi for a normal function, correct? So when the input, so when do I end is when the input is 2 pi. This is gonna suck a little more, but we're all able to do this. We're gonna add pi over 4. So I gotta get LCD, yes? You guys with me?
Yeah.
So again, where do I normally start? At 0. So if I make the inside 0, I'm gonna see what x value does this freaking weird ass function start at. Where do I end? Normally when it's 2 pi, if I solve for x, I'm gonna see where does this new freaking function wanna end at. So somebody help me out. 2 pi over 1, how do I make it like denominators of pi over 4? Multiply by, oops, sorry. 1 LCD, yes? Multiply by 4. So we get 2x equals 8 pi plus pi. Stop for a minute. Relatively, that's not bad. We need to know how to make LCDs. Don't make this shit decimals. That's what makes it bad. So what do I do now? I take 1/2 of each side to kill that 2, yes? So where does it end? 9 pi over 8. Now real quick, guys, real quick. How far apart are those two things? If it starts at pi over 8 and it ends at 9 pi over 8, how far apart are those?
2 pi.
Pi is 8 pi over 8 apart, correct? Which is pi. And what was our period supposed to be? Freaking pi! That kicks so much ass. I already know my period's supposed to be pi. So it's nice confirmation. You begin here, you end there. That matches with what we know the period's supposed to be. It should take it pi to get done with its stuff. Okay, let me stop for a minute. I know I use very technical language. Trig stuff. And this is the first time you're ever seeing this, so just give yourself time to kind of like let it sink in. The beautiful part about doing this kind of thing is you can kind of check with yourself as you go that everything's kind of matching up, and also you don't have to apply each shift separately. Now, right now, I could graph this, and then I'm going to come back and show you one more thing just to make a complete picture, but to graph this, I don't even really need that thing. So let me capture everything we know, okay? We know that the period of our new function, let me put the new function in. We know the period is pi. We know the step size, pi over 4. I know I'm going to start at pi over 8, and I'm going to end at 9 pi over 8. Now very quickly, all right, I'm throwing a lot at you today, so stay with me. Is everything I've said so far, if it doesn't make sense, can you at least see how, if you think about it, it will make sense? And maybe it does make sense, which is the ultimate best place to be. But trig functions, they are so freaking well defined, and they're so nice that if I just identify one piece of it, I can start to talk about where is that going to move to. So when I do the beginning and end work, it just tells me where's it now going to begin, where's it now going to end. And then if I just check that against the period, I can see if I'm on the right track. And sure enough, the difference between those is our period. That kicks ass. It's what it's supposed to fit within, is within 1 pi worth of motion. Okay. One little thing I want you to notice, I start at pi over 8, but every step I take is based on fourths. Do you see that? So I'm going to be nice to myself. Can I make the step size something out of 8? Pi over 4 is equal to what over 8?
Pi over 8.
Okay, now, let me just show you how this works. If you do a few of these problems, you'll start to get the feel of it. So I'm going to start at pi over 8. And my step size is 2 pi over 8. So where am I going to go next?
2 pi over 8. 3 pi over 8.
3 pi over 8.
5
5 pi over 8. 7 pi over 8. 9 pi over 8. And why am I happy? Because that's where I said I was supposed to end, yes? You see how the nice thing about this is it's a little repetitive, but you have checks and balances. Are you ending where you're supposed to, right? This is a sine function. So where does the sine function start? Does it start at the maximum or does it start at 0? 0. So at the first step, where I begin, start at 0. Where does it go from there? Does it go down?
Goes up.
Goes up, right? So sine function looks like yeehaw. So it's going to go up to 1. See, here's the beautiful thing. Now that I've got my steps, starts at 0, goes to 1, goes back to 0, goes to -1, goes back to 0. That's what a sine looks like. That's what a cycle of a sine looks like. Are you guys at all with me? Okay. And then you just have to fill it in. That's not the greatest. That's not terrible. It's got a little bit wobbly at the end, but it was sitting out in the sun for a while, yeah.
So we don't go, it's okay if we don't go all the way to the left, like to get past to the y line?
I'm gonna normally want one cycle from you, but always make sure you tell me that it goes forever in both directions, right? Is it really time?
Yep.
Jesus. Alright.
I'm
I'm sorry, guys. I wasn't even paying attention. Let me give you this. There was one more thing I want to say, but let me at least give you this. I'm sorry I kept you long.
Is this for 4.2 or still 4.1?
This is 4.2. 4.1 just talked about the new period stuff. So I have an example up there. There's one thing we haven't talked about is the phase shift. I talked about it before, but I didn't talk about how to get here, so we'll do that next time. Sorry, guys. Have a good night. If you have a calculator, don't run away. Please get your stuff back. Whew. Oh, sweet. Yeah. What'd you give me? Oh. Is this you?
Yeah, I know. I cut my hair and they didn't really.
Oh, okay. I got you. I'm not a cop. You're good.